to the WPI Podcast. I'm Colleen Shaver. Today, we're talking about the growing impact of K-12 robotics programs and how they're sparking curiosity, powering creativity, and helping students build the skills that drive innovation. For many students, designing, coding, and competing with robots is more than just a fun challenge. It's often their first real experience with engineering, teamwork, and hands-on problem solving. At Worcester Polytechnic Institute, robotics is part of the university's DNA. WPI has long helped fuel the pipeline of future engineers and roboticists, supporting robotics teams across the world while welcoming many of those same students to campus to continue turning bold ideas into working technology. Joining us today is Colleen Shaver, the director of WPI's Robotics Resource Center, who works directly with students, educators, and teams to expand access to robotics education and help young innovators gear up for the future of STEM. Colleen, thanks again for agreeing to be on the podcast. For listeners who may not be familiar, can you explain what K-12 robotics programs are and why they've become such an important part of STEM education?
Absolutely. So K-12 programs are for kindergarten through grade 12 to just engage in robotics or other enrichment opportunities in robotics, in engineering, science, technology, math, all of that. One of the things that they do is they really teach these students how to work together to solve real-world problems, and they inspire students early, and what we see that does is make them more interested in these kind of careers later on, the earlier that we can engage them in these technical achievements and gives them clear pathways to careers in those types of fields.
It's hard to think of a kindergartner doing robotics, but we're in a new world, and what you just said, working together, thinking creatively, you can find that in a kindergarten classroom.
Absolutely.
So why does robotics tend to be such a powerful entry point for students in STEM fields?
I think it's for the same things that we've learned here at WPI, which is that hands-on and project-based learning is one of the most effective ways to get kids of different experiences and different learning styles to actually engage and remember the content that they are learning. So it's the bridge between theory and practice, and you can start with practice, and then as you learn, you can learn skills and get deeper in different areas based on what you want to know more about.
You touched on this a little bit, but beyond the teamwork, what kind of skills do students develop through robotics programs that go beyond building robots?
I think one of the biggest things they learn is critical thinking and how to solve open-ended problems. Very rarely in robotics is there a right answer or one way to solve the problem. And so what we see is that, especially when they work in collaborative groups, that how do you fairly and objectively compare ideas when there's no right answer? It's not calculus. You're not going to do the math and it comes out with pi as the answer. So when there's no clear path to get to the answer, you have to really figure out how to work collaboratively, use everyone's skills to the best of their abilities, and then come to a solution and how to measure when it's successful.
And sometimes failure, restart to success is the real key.
Yeah, iteration is a huge part of robotics. And how do you improve along the way without trampling on other people's ideas and keeping everyone in mind?
So, Colleen, you've been here at WPI for many years in different capacities, but in a lot of robotics resource capacities. Just give me a little bit of your background and why you're such an expert.
I'm mostly an expert through practice, through doing it. So I was privileged enough to have access to a robotics program when I was in high school, which really inspired me to want to work with it more and continue working with it as a way to give back to my mentors and what they gave to me. I actually graduated from WPI. I have my bachelor's and master's from here, neither of them in robotics. But
Really? I didn't know
that just shows what the diversity of skills needed in robotics can be. And then I worked at FIRST for a little while developing games and teaching mostly K-12 students in robotics. And then way too long ago, I came back to work here and have been working in the Robotics Resource Center ever since. So running events, managing competition teams, and doing all sorts of things related on the outskirts of robotics, but related to bringing those programs to more students.
All right. And WPI, even before you, has long been associated with robotics and robotics programs. Why do robotics competitors, former competitors in a number of different programs, feel so at home here?
I think one of the reasons is that it's the next logical step. Like I said, a lot of robotics competition shares some of the same values we do at WPI, which is, again, hands-on project-based learning. And one of the things that I think makes WPI unique is that you're doing that group work that they've been doing all through high school or middle school day one when you get here. So you might be in the freshman robotics engineering lab working side by side with someone you just met, trying to solve an open-ended problem and make your robot do these various tasks. So it's directly related to what they've been doing because, again, it's the real practical way to teach large groups of people. So from day one, they're in the labs, they're in the machine shops, they're building real things while also learning, again, getting deeper into the actual theory behind what makes it work so that they can improve, again, build on those skills.
Accelerates friendships too.
That, and just, again, the learning how to work, I think one of the biggest skills in robotics is learning how to work with people that don't think like you do and learning how to use that as an advantage instead of a detriment to what you're doing.
When robotics students visit campus and interact with WPI, what usually surprises them about the opportunities here?
I think one of the biggest things is, again, that the focus on undergraduate education and the focus on what they're doing from day one as freshmen. And so to see that, A, it's a place that there's a lot of other kids like them, and then that, again, they jump right in from day one and they're doing very similar things to what they were doing in high school. So it feels comfortable as a way to get in, to feel like you belong right away, but then you take that to the next level when you're here.
So you're able to speak their language, entice them, but also get them to continue to be excited by new learning, new gadgets, new technology, new opportunities.
Absolutely. And just to see the number of fellow students that came from robotics teams, because you'll walk out on the quad and a dozen kids with their team shirt on or from a different event that you've been to. And I think that alone makes kids feel seen and, I know that team or I know that shirt, and they feel like that they will relate to the people here more than they would maybe some other places.
That's great. And maybe some of those teammates or former adversaries have seen each other or seen each other's robots, and they've competed here at WPI. Do you find that as well?
Absolutely, especially obviously our kids from the New England area who come to our campus regularly for events. I've seen it multiple times where now that's their freshman roommate. That's how they connect to each other as they both realize, oh, I'm going to WPI. Hey, I know you like robotics too. And even if they don't continue in these programs when they get here, because there's so many hundreds of other clubs to do on campus, that they just, again, that they find that as like the common ground that can be the scariest thing, I think, when you're coming to college for the first time is how will you relate to all these new people?
Yeah, let's talk a little bit more on that and what you said about maybe they're coming here and they were from a robotics team, but they're not going forward in the robotics engineering program, or they decide that they want to add on another club. I think that's important. And back to your background too, you were not a robotics major. So how does this skill set, experience, opportunities that are afforded in those robotics programs manifest in different areas of STEM?
I think what you can quickly see is that robotics and the skills you learn touches a little bit of everything. Robotics as its core is very interdisciplinary. It's mechanical engineering, it's electrical engineering, it's computer science. but it's also the humanities, and it's also all the different soft skills that you learn with it. So sometimes we think of robotics and we just think of your traditional thing, or you think about a warehouse robot that's moving around, or a robot arm that's building a car. But robotics is assistive technologies. It's powered prosthetics and wheelchairs, or it's agriculture, and how do we help farmers better manage the water and the resources that they have for growing their plants. So robotics really can touch any level of interest that you have because of its interdisciplinary nature. So I think sometimes when we look at it from the outside, people that don't know, the intimidating part of robotics is that's just not for me, or it's not what I'm interested in, but it really can cross so many different barriers.
Is it important to get students at an early age?
I think one of the most interesting things about engaging students early in robotics, in STEM in general, is overcoming the fear of what it is, or that I don't belong in that field. Because as they get older, there's just the natural self-selection biases, or biases in the world about who belongs in STEM and robotics. And the earlier we get kids involved is before society has told them that they don't belong in this field. And what's really important for the advancement and innovation in robotics and STEM is unique ideas and the things that all different perspectives bring to the table. So the earlier we can get people involved, the more their foot is in the door and they realize, oh, okay, I can do this. This is where I belong. And then they're more likely to stick with it as they move on, versus if you wait until high school or college and you've never had a student engage in STEM, why would they think that they'd go into college for a STEM major if they've never had the opportunity and access to do STEM before that, or they've never been encouraged because of background and or experience and all of that to engage in STEM. So I think that's why it's really critical that we do these K-12 programs, because it lets kids have an entry point and say that, hey, this is a place, there's all sorts of things you can do in this field, and here's the different types of careers it can lead to, or why you should go into it.
Awesome. So, Colleen, I introduced you as the director of the Robotics Resource Center at WPI, which for listeners, they should understand this is separate than our robotics engineering program. So explain what you do, what your center does, and how that gives support to these K through 12 programs.
Absolutely. So the Robotics Resource Center was formed to support all the work that we are already doing and formalize the work we were doing in supporting these K through 12 teams and initiatives. So we run the gamut in what we do. We run robotics competitions. We host events all throughout the year for students from all over the world to come to campus to have the opportunity to showcase the robots they've built through these different programs. And that's a huge part of what we do. We also develop supportive technology like software libraries, things of that nature that can support the teams. And again, the idea is that when you give people all the basics, you level the playing field and you help more teams see success. And when teams go out on the field and they feel like I'm capable of competing with these other teams, they're more likely to stay with it. They're more likely to want to learn more skills in order to do better. So that's one of our major goals there. We also write curriculum and do other things, which is to help improve access to the schools and to the students that don't already engage in these programs, or through various reasons that they may not be able to. It could be anything from you're just in a really rural area that it's hard to get to competitions or to these greater interactive things. So what can we help you bring to your classroom? On a more specific scale, to say FIRST robotics competition teams, WPI has a full practice field. We share our machining resources. I just got a message right before this for a local team asking for help machining something. And so our kids will do the work and help those students machine something so they can get on the field and compete with their robot.
What kind of feedback have you gotten that tell you you've made a difference, you personally and or the Robotics Resource Center?
I think one of the major things is, for example, we had a rookie team that came to our workspace just to see an example of a robot and all that before they got started. We have a community resource bin where other teams as well as our team can donate parts that we don't use anymore that they can take, and they left with 3 bins worth of stuff. And what it does is lets them use the limited funding they might get as a rookie to expand and not just have to buy the basics to compete. When they send a picture of that base robot together, you can see the excitement of their kids because they were able to put it together and they know it looks like what other teams do and not maybe just like a rookie bot that got thrown together. That's really exciting because we know that's going to help that team continue next year, attract more students to the team, and just overall give those kids a better experience because they don't feel like they're necessarily behind the 8 ball because they didn't have the same leg up that someone like our team who's been around for 35 years has just from the nature of experience. So
that's great. I didn't know that either, so that's really great. For parents listening who have a child who is interested in robotics or STEM in general, what advice would you give them?
My best advice would be, and this is from hearing from parents that often reach out and say, hey, how do I cultivate my kid's interest in this, or how do I get involved, is that you have to overcome that intimidation yourself to get involved, because there are lots of the programs, especially for ages like 6 through 10, that are primarily coached and mentored by parents, by their nature. So First Lego League is an example of a program that they're small teams, usually groups of kids that are friends, and they just need a parent to be their coach. And I hear a lot of parents saying, oh, I can't do that. That's not my area. I don't know how to code. I don't know that. And we expect our kids to step up when they don't really know and be willing to try. So let's just be willing to try. All these programs are built that the students can start out on their own. The resources are there. They're written for your average 8-year-old to figure out. And then you just need to be there to facilitate and make sure they're working together and there's someone there to watch over them. And then you can learn those skills as you go with the students along with it. So I think especially too, our kids might say, my parents a little scared of that. And so I'm not really sure about that. And that's one of the reasons we might self-select out of these programs. And so even if it's a parent that has no knowledge of STEM, but knows it's a good experience for their kid, to not be afraid to step up and say, okay, I can take this on and I know that the resources are there to help me get started, and the kids will have a great time either way.
All right, let's flip it. Same question, but what advice would you give a young student who's interested in robotics, but they don't know where to start?
That's maybe even a harder question, but I would say to start with just some basic research. The internet is full of ideas and concepts of what people do with robotics. And so one of the easiest ways to find your niche, find what drives you and interests you, because robotics is not going to look the same for everybody. It's going to look very different. So where is the area that you're most interested in? And then you can start thinking about, how would I use robotics to solve this problem that I think is interesting? And then you can say, what skills would I need to solve that, and start learning those basics. But always, I would say, take the class, try the after-school program, whatever it is. And if your school doesn't have any, to talk to your administrators and your teachers and say, hey, I think it'd be really cool if we had this robotics program or this kind of after-school club. And I'm sure you can find the support in your school to do it.
How important is it to not just support the students, but also the teachers, mentors, and parents who help make these teams possible?
Yeah, one of the reasons it's critically important is because these teams and these programs don't exist without the mentors and coaches, most of whom are volunteering their time to support these teams and these programs. So we really want to do the best that we can to support them. As an example, we host a mentor conference here on campus. We build a lot of different resources online for the mentors specifically to use. We participate in mentor support Slack groups and forums that help answer questions for other mentors. It makes it so when the kids ask them those questions, they don't feel like they're blindsided, because not every team has the breadth of mentors that have deep skills in mechanical, electrical, non-technical things. So we rely on each other for support. And I think one of the unique things about the Robotics Resource Center is that we are all mentors ourselves. We mentor a team, we've mentored other teams, and so we're able to understand the unique challenges that those mentors face in their everyday management of a team and speak from a position of a coach and a mentor as well.
Great. Looking ahead, how do you see robotics education evolving over the next decade, especially with technologies like AI continuing to grow?
I think in the next decade, we're probably going to see a change of the skill set of what students are learning because AI is so prevalent and we don't fully know how to use it in the most productive way to build our skills and use it as a resource and as a tool and not as the answer to what we're doing. I think we'll just keep trudging forward, teaching kids the skills we know they need. And there's so many parts of engineering that AI can't replace. And we can use those skills to say, if I want to build a bridge and make sure, do the finite element analysis, whatever it's called. We've reached already over my head of skill. But if we want to do the strength analysis of a beam, AI can help us with that. But we still need to know the basics to put into it to get started on how to build it and how to make it look good in our cities and not be a detriment to the environment or to the skyline or whatever it might be. There is and always will be a human part to what we do, and we just need to keep teaching our kids the skills to know how to use that and then use the tools they have at their disposal.
All right. Colleen, you answered all of my questions, and you really gave a great overview of how these programs are fun, but really so foundational into how a student can grow throughout their life. So thank you for all you do in your center. And as people call you, the original Colleen here at WPI, you were here before me and have done so much in so many different ways, from the new C to the OC. Thank you.
Thank you.
This has been the WPI Podcast. For more episodes, visit wpi.edu/listen or find them wherever you get your podcasts, including Spotify, YouTube, and Apple Music. Whether you're a future student, a member of the campus community, or just wondering what the school is all about, this is where you'll meet the people and projects that make WPI extraordinary. Thanks again to Colleen Shaver for being today's guest, and to Varun Bhatt, our audio engineer in the Global Lab. And as always, thanks to you for listening.